The following video is designed to provide you with a quick step-by-step guide of how to develop a soil model for use with the EDG to determine the density, moisture, and percent compaction of construction materials. Please refer to the manual for a complete explanation of the process. In order to use the EDG, you must develop a soil model for the specific material you wish to ultimately test. A soil model provides the necessary data for the EDG to make accurate determinations of density and moisture, as well as percent compaction. Soil model data consists of two types of test data. Field tests, which collect the necessary data to create a working curve of densities and moisture, which relate to specific readings made by the EDG, and laboratory tests, which consist of the standard ASTM Proctor tests used to determine the compaction characteristics of the material to be tested. The results of these tests will be entered into the EDG to help it determine the percent compaction readings. To quantify the readings made with the EDG while developing a soil model, it is necessary to run a conventional method test such as a nuclear gauge, sand cone, voluvessel or drive tube, as well as moisture tests at the same time. If you plan to use the nuclear gauge for this function, it is recommended that you still use an alternative test for moisture, such as oven dry, speedy, or field burn-off methods. The reason for this process is that it correlates actual compaction and moisture numbers to the readings obtained with the EDG, which provides the information the EDG needs to make accurate determinations. This regimen only needs to be done when developing a soil model. To begin building your soil model, first turn on the EDG by pressing the power button on the keypad for a few seconds and then releasing. Once the EDG is on, please allow the EDG to warm up for 5 minutes before proceeding. When you first turn the EDG on, you will see this Home screen. Since we are concerned with setting up soil models in this video, we will press the Soil Model button, the icon with the red helmet. If this is the first time you've used your EDG, you should be looking at a screen that looks like this. To begin, you will create a soil model project and name it. Press the Projects button, the top right button with the folder icon on the touchscreen, or the Project key on the keypad. You will see this screen. You will want to create a new soil model. Press the New Project key. A keyboard will be displayed entitled New Soil Model Name. Use the keyboard to type a name for your soil model in the value field. The name can be up to 8 characters long, and you may want to use a name that refers to the soil type, date, location, or test reference number. Once you've created the name, press the Select button to save the soil model you have created. Once saved, a screen with your soil model name will appear with no data, stating "No soil tests available." On this screen, press the Model Details button on the top right of the screen. This screen is used to record your Proctor data, as well as making a determination of the soil type you are working with using a list of the unified soil classifications. If you already have Proctor data for the material you are going to be testing, enter its maximum dry density and its optimum moisture in the appropriate fields. Simply press the Max Dry Density field, and a keyboard will appear for you to enter data into that field. Once you've entered the data, press the Select button, and your info will be saved to the field. Now you can add a value to the Optimum Moisture field. Click the field, and the keyboard will appear. Fill in the data and press the Select button, and it will be saved. In actual testing, the maximum dry density and the optimum moisture data will be used by the EDG to generate percent compaction results. Next, press the Classify button at the bottom left of the screen. A scrolling list of the Unified Soil Classification descriptions will appear. Find the soil classification that best fits the material you are testing. Click on it to highlight and select it, and press the Done button at the bottom right to save this description. You can also choose None or Other for this description. If you choose Other, you will have the option to type in your own description. If the data displayed is not correct, you can alter your information by pressing on the appropriate fields or the Classify button to make changes. If it is correct, press the Apply button at the bottom right of the screen. Upon pressing the Apply button, you will see this screen. Press the Save button and you've created a name for your soil model. To begin working with this soil model, press the green Select button, which selects your soil model for use and turns the green dot to gray to show that it is selected. Press the Done button. You will see this screen. To continue to build your soil model, the name of the soil model on the left should be highlighted in blue and the Select button should be gray. By selecting this specific soil model, any tests performed while it is selected will be linked to it. Please note, if no soil model is selected, testing cannot be performed. Press the Back button at the lower right of the screen. This action will take you to the current soil model screen. The screen will indicate a fit of 0 and state, "More soil tests required to calculate fit." Do not be concerned with the fit at this point. It will be discussed later. You are now ready to proceed with the actual soil model development at your test site. To begin, you will need the EDG and its test accessories, as well as the equipment for one of the following traditional test methods: nuclear gauge, sand cone, volute vessel, or drive tube. You will also need a moisture determining apparatus, such as an oven, speedy moisture tester, or a field burn-off tool. What you are trying to accomplish by building a soil model is a curve, which illustrates the density and moisture characteristics of the material you wish to ultimately test. This curve will be comprised of a series of tests, typically 6 to 12 tests, of the material at different levels of compaction effort and different levels of moisture. To produce a soil model, traditional test methods, such as a nuclear gauge, sand cone, volute vessel, or drive tube, will be performed simultaneously on the same location as each of the EDG tests you perform. This method links the readings obtained by the EDG to actual density and moisture readings obtained from the traditional methods. By using the EDG in conjunction with the traditional method for providing density and moisture readings, a curve is developed, which provides an accurate depiction of the material's properties for varying density and moisture readings. It is this curve which allows the EDG to then produce accurate readings in subsequent testing of this specific material. You are now ready to proceed with the actual soil model development at your test site. The test site can either be the actual project site you desire to test, or a site that uses the same material that you will be using at your project site. When building a soil model, you should use a dart length that coincides with the expected lift height that you will be using for the project. Darts are available in 4, 6, 8, 10, and 12 inches. Select areas on the job site where the type of soil is consistent from place to place, and where there are differences in water content and compaction. Special preparation of areas of different densities or water content should be done the day before testing, so as to allow stabilization of the soil water content. As outlined in ASTM D7698, a matrix of 6 spots should be used during the calibration procedure. These spots should consist of 2 different soil density conditions with 3 different water contents for each one, which cover the range anticipated with the specific material. The 3 calibration tests that evaluate high-density soil should use test locations that ideally have soil conditions that are close to the maximum density as determined by test methods D1557 or an equivalent. The range in water content should include low, middle, and high water contents. It is near the optimum water content as determined by test methods D1557 and D2216, or equivalent test methods. To begin, place the gauge on the ground near you and open the case. Turn the gauge on and remove the gray circular dart template from the lid of the case. Place the gray dart template on the ground. Remove the accessory caddy from the EDG case and place it on the ground out of the way. Remove the hammer and the 4 darts from the bottom of the case. Position a dart at each detent of the dart template and hammer into place. The shoulder of the darts should be level with the ground surface. Darts should be driven straight into the ground, not more than 20 degrees from vertical. If rocks are encountered during the process of driving the darts, which prevent the driving of a particular dart, move your test site slightly to accommodate the rock. Unscrew the cap to the sensor port located on the front base of the EDG case, the right of the handle. Remove the sensor unit from the accessory caddy and attach the black cord attached to the sensor unit to the sensor port. Then, attach the sensor unit, pins up, to the center of the gray dart template, using the Velcro fastening system attached to each item. Remove the 2 cables which are used to make a connection between the darts and the sensor unit. These cables have an alligator clamp on one end and a 1/4 inch phono plug on the other. Attach the 2 cables to the sensor unit using the 1/4 inch phono plug ends of the cables. Then, take the alligator clamp end of each cable and attach each one to a single opposing positioned dart. When attaching cables between the darts and the sensor unit, it is best to have as straight a run as possible. The cables should not cross. Care should be taken not to cross the cables when switching them from the AA position to the BB position during the testing process. Remove the thermistor, or temperature sensor, located in its plastic case in the accessory caddy. Plug the thermistor into the mini phone plug port located on the side of the sensor unit directly above where the black cable enters. Remove the T-handle probe from the bottom tray of the EDG case and use it to create a hole away from the dart template into which you will place the thermistor. The placement of the thermistor is not critical and only needs to be placed beneath the surface of the material. You are now ready to begin running the first test for your soil model. From this screen, simply press the Test button at the bottom right of the screen to begin a test. When you press the Test button, this screen will appear. As the directions on this screen state, verify that the soil sensor is connected to the darts. Make sure the wires connected to the darts are not crossed. Make sure the temperature sensor is connected and inserted into the soil. The diagram on the screen illustrates which darts should be connected for a test. Tests always involve connection to opposing dart positions, or in the first instance, A and A. The diagram on the screen illustrates the correct position of the darts to use. Press the Perform Electrical Test button. Once this is done, the gauge will perform a test and a new window will appear, telling you to switch the dart positions to the B and B position. The diagram on the screen illustrates the correct position of the darts to use. Press the Perform Electrical Test button. The gauge will now perform the second test. You will now see this screen. At this point, you can ignore the numbers in green and the reference to fit. Fit is not calculated until after the third test. We will discuss fit later when we begin looking at the curve we generate. The first 2 tests you perform when building a soil model will also include this statement in red. More soil tests required to calculate fit. This will not appear after the third test, as fit will begin to be calculated as you build your soil model. Press the Save button. You have saved the first point on your first soil model test. Now that you have conducted the first test of your soil model, you will also need to run a test on the same spot using the traditional density and moisture test method you have chosen to use in conjunction with the EDG. Complete this test and maintain the results. When you are finished, you will enter the results of these tests into the EDG. If the method you have chosen to use provides results on site, like a nuclear gauge, you can enter the results into the EDG as you build your soil model. Or you can wait and enter all the results when the traditional method results are available. To complete your soil model, you will need to do a total of 6 to 12 tests with a range of different compaction levels and different moisture levels. Perform your next test, move to a new spot, and repeat the testing process you used for your first test. When you have completed your tests, you are now ready to match the results of your traditional density and moisture tests with the EDG soil model you have constructed. Follow these steps to enter your information. From the soil model screen, press the Select button. You will see this screen. On the left is a scrolling list of the soil tests you made with the EDG. Select one at a time and fill in the corresponding data for wet density and moisture content, which you recorded with your traditional method testing apparatus at each test location. Select the field for wet density by pressing on the yellow field. A keyboard will appear for you to enter the corresponding value from your first traditional method test. When you have entered your number, press the Select button on the keyboard. Your wet density value is now displayed in the field. Select the field for moisture by pressing on its yellow box. A keyboard will appear for you to enter the corresponding value from your first traditional method test. When you have entered your number, press the Select button on the keyboard. Your moisture value is now displayed in the field along with the wet density value. Once you have completed entering the wet density and moisture values for each soil model test, you can view the graphs or curves which make up the soil model. To view the graphs, press the Graphs button at the bottom left of the screen next to the Trash button. There are actually two graphs which make up your soil model. The first is the impedance versus wet density graph. The graph should appear similar to this. The second graph is weight of water versus CR, which you can view by pressing the Next Graph button on the top right of the screen. It will appear similar to this. Each point or soil test on either graph or curve can be evaluated. To do this, use the back and forward arrows at the top right of the screen. Using the arrows cycles you through the different points on the graph, and the corresponding number of the current point is shown between the buttons. The current selected point will be highlighted as a green box on the graph. In addition, each individual point of the graph can be enabled or not. The gauge defaults to all points of a soil model being enabled. However, you can turn off individual points. This is typically done to eliminate outlying points from the graph to achieve a tighter fit for more accuracy. You have probably noticed the word fit with a corresponding number on the screen for each of the tests you have run. Fit refers to the overall accuracy of the curve you have developed. A fit of 1 is perfect, and while you can operate with any fit, for accurate and reliable results, it is recommended that the fit be above a .600 reading. Here we can see what happens to the overall fit of your soil model curve when you eliminate an outlying point from the graph. Here is the original graph with the fit of 0.331. Point number 1 is selected, which is indicated by the green square on the graph. This point is not close to the curve indicated by the white line. Clicking on the green check mark in the box next to Enabled turns this point off. By turning off outlying point 1 on the graph, the curve is redrawn and the fit improves to 0.732. This creates a much tighter and more accurate curve, which will result in more accurate readings when using the EDG. To save these changes, press the Back button, which will return you to this screen. To save these changes, press the Save button, which will return you to this screen. To close this screen, press the Done button, which will return you to this screen. At this point, your soil model is complete. Press the Back button to return to the soil model testing screen. You are now ready to begin actual testing using the soil model you have created on the specific material you used to build your soil model. You will want to return to the home page, so press the Back button. To begin actual soil testing, press the blue helmet icon on the top right entitled Job Sites. On this screen, press the Projects button. From this screen, create a new job site by pressing the Add button in the lower left of the screen. A keyboard will appear. Type a name for your job site and press the Select button. You've now created a job site and need to assign a soil model to it. To do this, press the Soil Model Selection button at the lower left of the screen. Until you actually select a soil model, the Selected Soil Model field will say Unselected. To select a soil model, press the drop-down menu under Choose Soil Model and choose the soil model you wish to assign to this project. Press the Apply button at the bottom right of the screen. You will see this screen. Remember, once a soil model has been selected or linked to our job site, it cannot be changed. Press the OK button. Again, remember, once a soil model is linked with the job site and saved, it cannot be changed. Also note that changes to the soil model will not take effect on the current job site. Essentially, what this means is that once you link a soil model to a specific job site, the data in that soil model in relationship to this specific job site is frozen. While you still can add points and change data to the original soil model, those changes will not affect the current job site to which it is linked. Thus, after linking a soil model to a job site and proceeding with actual tests, you will not see changes to your results if you go back and add points or change data in that original soil model. However, this does not prevent you from making a copy of the original soil model, altering the data, or adding points, and then linking this new soil model to your job site. It also does not prevent you from linking a new and different soil model to your job site. After pressing the OK button, you will see this screen. On this screen, you can see your job site at the top and at the bottom in red the soil model you have linked to it. Press the Save button. You will now see this screen. You can select this as your working project by clicking on the green Select button at the bottom right of the screen. The Select button will turn gray, indicating it is selected. By clicking on the Select button now, you will pre-select this combination of job site and soil model, saving you a step when you go to use this combination for testing. Click on the Done button, and you are ready to begin testing. You will see this screen. You are now ready to begin actual testing at your job site. Testing follows the same process you used to create your soil model, except that you won't need the traditional methods anymore.